Hi, everybody. Welcome back to our mini series on bumblebees and community science. Again, my name is Cole Blair. I'm the lead biologist with Wildlife Preservation Canada's Native Pollinator Initiative. And we left off with just a brief intro on who we are at Wildlife Preservation Canada and what we do in the Native Pollinator Initiative. And now we're going to get into the actual content of things. And the first thing I want to talk about is differentiating what is and isn't a bee. So if you imagine we're out surveying for bees, if we're in a community science program, or if we're just on a walk and we're seeing things buzzing around flowers, we think to ourselves, this might be a bee. I can contribute to some community science monitoring data. But we have to ask the question, is this really a bee? So there are a few different ways that we can differentiate bees from other pollinators that might look alike, such as flies and wasps. Anatomically, this first point might be hard to differentiate if we're just observing bees on flowers. But the first thing I want to note here is that flies only have one pair of wings, bees and wasps will have two. Again, not something you might be able to note if we're just observing insects buzzing around flowers, but it is a difference nonetheless. Another thing we note when we see bees, flies, and wasps are differences in the antennae. Again, this is going to be a difference mainly with flies because they have really, really short, stubby antennae, often hard to see. Bees have longer antennae, as we see in the diagram here. They kind of jut out in a straight line, and then they have a kink in their antenna. And after that kink, there's another extension of antenna. So you have that obtuse angle from the kink. Wasps also have longer antenna, but they're longer. So they have quite long antenna, and they get to be so long that oftentimes you'll see them hoop down um, almost in this like swooshing manner. So a little bit different from bees, though again, they both have quite long antennae in comparison to especially flies. Another difference between these different insects and what is and isn't a bee is the presence of scopa. And this is where bees start to differentiate between from flies as well as wasps. So bees are characterized by having these pollen collecting hairs called scopa. And this, as the name suggests, helps bees coat themselves in pollen and then also guide them into their pollen baskets. So bumblebees in particular have their pollen baskets situated on the mid part of their hind leg. And that's what the diagram is showing here. We see this glob of something here on this bee's hind leg. That glob is actually pollen. And that part of the hind leg is where the pollen basket is situated. So the scopa, the pollen collecting hairs, are helping to drive the pollen that this bee goes and collects from different flowers into that pollen basket. Flies and wasps don't have scopa, so that would be a primary distinction between bees, flies, and wasps. Bees have these scopa and their pollen collecting hairs because they need a lot more pollen because they're not just feeding themselves, but they're also bringing that pollen back to their colonies where they're feeding dozens or hundreds of other bees. So um, the pollen collecting hairs become very important for that bee in their foraging processes. Another distinction between flies from bees and wasps is the face. So when we look at the face of a bee, a fly, or a wasp, what we notice is that the face of flies is comprised mainly of the eyes. So the eyes take up much of the face on a fly, and they're often very, very close together. So in conjunction with those stubby antennae, you'll be able to tell what is a fly just by looking at the face. Bees and wasps can also have large eyes, but they won't be nearly as large in relation to the rest of their face as we would see with the fly. And of course, we would also see those longer antennae. The final distinction that I want to make between bees, flies, and wasps, and this also relates to the prior point I had made about scopa, and particularly with bumblebees, is that bees have wider legs often compared to flies and wasps. Flies and wasps, for the most part, are going to have thinner legs. Wasps as well will have that threaded waist in comparison to the more robust bodies of a bee. So, in summary, bees, two pairs of wings, longer antenna. They'll have those pollen collecting hairs. In bumblebees, it will be driving pollen into the pollen baskets on their hind leg. But in some other bees, you might see scopa or those pollen collecting hairs on other parts of the bee bodies, like the underside of their bellies, their abdomen. And then also bees are characterized by having hairy and wider legs. You can contrast this with flies and wasps, which have no scopa, thin legs, and with flies particularly, having stubby antennae and faces that are mostly taken up by their eyes. So, with this in mind, I want to go through a few examples with you, and I'll tell you, um, practicing these distinctive traits here, what is a bee, a fly, or a wasp? And I have some examples. So, this first one here, we see it's pretty hairy throughout. The legs look a little bit wider. This kind of looks like a bee. It's yellow like a bee, it's hairy like a bee. But we look at the face and we see little antenna and huge, enormous eyes. And that's what's going to tell us that this is in fact a fly. So this is a kind of fly that's mimicking a bumblebee. So with that in mind, we see again smaller antenna, big old eyes. We can tell that this is a fly. This next example, this one might be a little bit more obvious. We see a threaded waist and thin, skinny legs to indicate that this is a wasp. This next one might be a little bit trickier, but we see that it's still hairy throughout. It's got these longer antennae and these wide, hairy legs. But we also see that there is scopa. As I'd mentioned before, sometimes bees have their scopa not on their hind legs, like we would see with bumblebees, but sometimes they can be in other parts of the body. And with this individual, we see the scopa underneath the underside of the abdomen. So if this bee were packed with pollen, it would be on the underside of its abdomen. But again, we see those scopa, those pollen collecting hairs, wide, hairy legs, and longer antenna to indicate to us that this is a bee. Similarly, with this example, again, we see longer antenna. It looks a little bit relatively hairless. This might be a wasp. However, we do see, again, thicker legs that are covered in hair. That would indicate to us that this is another bee. Final example here. Again, it's kind of yellow and black like a bumblebee. It's hairy like a bumblebee. However, again, we see the face, mostly eyes, and those teeny tiny little antenna poking out. And it actually was misleading. I have one more example. So this one is a fly. This one, similar in color pattern to the last example. However, we can see that this is a bee. The arrow here is pointing at the midsection of that hind leg, and we see that triangular kind of juxtaposition. It's kind of jutting out with this right angle. If you squint, you might even see the bit of pollen that's packed in there. This triangle on the mid part of the hind leg is indicating a pollen basket. And we know that those are associated with bees, particularly bumblebees. So this is a bee. We also see it's hairy throughout, quite robust, and it's got these longer antennae that we wouldn't necessarily see with a fly. So we could tell simply from the presence of the pollen basket on the hind leg that this is a bumblebee. It's a bee. Now, through this exercise, we've kind of got a small glimpse into the broader diversity of the bee world. We saw a few different examples of bees. They all look vastly different from each other. And that's only a drop in the bucket in the greater realm of diversity in the bee world. So everything you're seeing on screen right now are different examples of various kinds of bees. And there is just a huge biological diversity in the bee world. There are more than 20,000 species in the world and more than 400 species of bees in Ontario alone. So a ton of different bees ranging in color, size, shape, um, speciality. Some might be more specialized in certain flowers or others. They differ in how and where they nest and things like that. But hundreds of species only in Ontario, 20,000 in the world. And what we might think about bees, growing up learning about bees, we learned about honeybees and bumblebees, kind of instilling this aspect that bees are these industrious social creatures that make these great big colonies. However, the truth is a little bit different from that. Sociality in bees is actually quite rare. Most bees are entirely solitary. They might group together at times in sort of semi-social clusters. They might nest nearby to each other, but by and large, they'll be described as solitary females with their own nests, rearing their own larvae and their own eggs. Um, No casts, no colonies that we would expect to see with a honeybee or a bumblebee. And to really hammer in how rare sociality is among bees, there are actually more species of bees that evolved to be parasitic, meaning they acquire their resources by stealing from other bees, than there are species that evolved to be social. So again, sociality being described by the different castes of things like honeybees and bumblebees, where you have a queen um, at the top, and then different workers and males um, all working together towards the same common goal. So there are more bees that steal and are parasitic than there are bees that are actually social. So this is quite different from what we might know going into this about bees. And these are just a few examples of the different kinds of bees that we might see here. Again, I'm in South Central Ontario. If I were to walk outside, I could very well easily find every single one of these kinds of bees. Again, most of them are solitary, and the ones that are solitary, we can divide into groupings based mostly on their life history. The most common of these would be things like the sweat bees, mason bees, carpenter bees we're all familiar with, um, cuckoo bees, again, being parasitic. Even leafcutter bees, I mentioned that some bees have those scopa hairs on the undersides of their bellies. This leafcutter bee that we see on the screen here has uh, pollen absolutely coating their different their scopa hairs on their undersides of their bellies. Um, so these are all different kinds of bees that we might see outside where we are right now. However, there's a couple different ones on here that I want to point out. The only two of these ones that are truly social are our bumblebees and our honeybees, which are not from here. They're not native. We brought them over from Europe in the colonial era. So really, the only true example of a native social bee that we have here in North America are going to be our bumblebees. Those are the stars of the show today. Honeybees are social, but not native. Bumblebees are social, but native. So um, we're really concerned with our bumblebees today. However, bumblebees are not just one organism. There are actually a bunch of different bees. There's around 46 different species in Canada alone. So they differ, as we can see in these illustrations, in size, different color patterns we see, different combinations of black, yellow, white in some of them, orange. They can even differ in their colony size. Like some bumblebees can make really, really large colonies with a few hundred workers. Some of them make colonies that might peak at around a few dozen workers. It just depends. Some of them have different lengths of tongue. So this might impact how well certain bumblebees can access various kinds of flowers. But despite all these differences between different bumblebees, they all have a lot of similar shared traits, especially with regards to their life cycle. So bumblebees follow an annual colony cycle, and we call it an annual colony cycle because the queens live for about a year. So I'll go through their entire colony cycle with you all right now, and I'll start in the spring. So if we take ourselves back to late April or early May, um, the frost has been thawed. It's been a little bit warmer consistently now, and so in the springtime, bumblebee queens will be waking up from their long winter's nap. So if you didn't know, bumblebee queens hibernate kind of like a bear does, or other mammals that kind of go dormant during the winter time. Bumblebees here in North America, especially in Canada, where the winters are quite harsh, they do the same thing. So the queen initiates this cycle by waking up in the spring completely alone, and then she'll try to find a comfortable spot to find a nest. And these can be in things like abandoned rodent burrows from the year prior. They can be underneath long tufted grass, um, or in or under leaf litter or other organic materials. But she'll be basically finding a spot to protect her and her nest from outside interference and maintain a somewhat stable environment of relatively stable humidity and temperature. So she'll be going out and finding a place to kickstart her colony. And once she's found an adequate nesting location, she'll then go out and forage for resources to feed her eggs. So she'll lay some eggs and she'll be going in and out, foraging from wildflowers to provide food to these developing eggs. As the time progresses into the summer, hopefully the workers will have been emerging from these eggs. And at this point, when there are workers, they will take on the dangerous task of leaving the nest and acquiring pollen and nectar, whereas the bumblebee queens will kind of take the role of stay-at-home mom, and she'll hang back in the colony and care for the developing eggs and continue to grow the colony. As the queen makes more and more workers and they're acquiring more and more food, we move into the late summer and into the fall. And at this point, hopefully the colony has a ton of workers. And this is when the queen will start to shift the colony stage into reproduction. So she'll start making the reproductive casts, and those reproductive casts are going to be males, and then also new queens, which we call at this stage gynes. It's spelled Gyne, plural is Gynes, and those gynes are going to be next year's queens. So at this stage, they're newly emergent queens, but they haven't mated yet, so they're not quite queens. They can't be queens yet. And at this stage, these males and these new queens, these gynes, are going to disperse from their colonies and hopefully find um, males and gynes of that same species from other colonies. And hopefully they'll mate, at which point the queens, after having mated, will disperse again. She'll stuff her face with as much food as she can fit, and then she'll find a hole in the ground basically to hibernate. And again, these can be under leaf litter, rotting organic material, under tufted grasses, abandoned rotor burrows, or what have you. But again, she'll be burying herself in the ground after having eaten a bunch, and then she will sleep off the cold winter. After which she will emerge back in the spring and kickstart the colony process again. So we think about why we call it an annual colony cycle. It's because the queens are produced in this late summer to fall period. If she's entirely successful, she'll go through the winter, spring, and summer stages and reinitiate a new colony, making more workers, and eventually reach the same point in the late summer and early fall where she'll make more gynes, more new queens to be the next year's queens. And at this point, once the cold sets in, it's now nearing winter. The founding queen that's produced that gyne, that new queen, as well as all of the workers and all of the males from her home colony, will eventually start to naturally perish, leaving only the newly mated gynes to overwinter completely alone. So again, we think of bumblebees as an annual colony cycle because the queens will be emerging in this late summer to fall period, and then they will be naturally perishing at the same point of time in the next year. And here we just have a couple representations of what a bumblebee colony might look like. On the right here, this is a brown-belted colony, brown-belted bumblebee colony, a brown-belted bumblebee nest. And we see that there's some bees hiding around in there. These capsule shapes, these are egg cells. So there are developing bees in these little capsules, and eventually they will emerge as fully developed bees. And we see some of these capsules have had the tops removed. And some of them, you might even notice, have that reflective sheen. And that reflective sheen is actually nectar. So these capsules with the tops off, especially the ones that are full of nectar, are nectar pots. So you can think of these as kind of emergency food storage, almost like a storm pantry. You know, bees don't like to be out if it's raining or excessively windy or excessively hot, like if there's weather conditions that are keeping them from going out and foraging, or if there's some sort of food scarcity. This allows the bumblebees to rely on the food that they've stored up throughout the season leading up to that. And on the left here, these are tricolored bumblebees, and these are actually gynes. So these are the new queens. This would be happening in the late summer period. So these are gynes that were just recently emerged from their eggs, and they are dispersing from their nests to go and hopefully find a mate. So these are specifically gynes that are going to mate over winter and hopefully kickstart a colony in the next year.